The next important topic in the mechatronics is design of mechatronics system. In design of mechatronics system, again, the classification is based on system. System is nothing but it is arrangement of elements in rationalized manner in order to achieve certain objective. What is the objective of system? Every classroom is a system. The objective of the classroom is just to impart the knowledge. That is one of the objective. Every system has an each and individual objective. So here in each system there is an objective. Again, the objective can be defined like what is the output and what is the given input. In mechatronics system, each systems will be segregated into what are the inputs and what are the outputs. Like that, different systems are classified. So here, the mechatronics systems are classified based on individual systems. Say for example, mechanical system, it is alone mechanical alone. Electrical system, electrical alone. Electronic system, electronic alone. Like that, depending upon the inputs and outputs type, the systems are classified into two groups. One is pure system and another one is combined system. In pure system, the name itself indicates pure. It is having same inputs. Input is also same, mechanical, output is also same. So the interactions are same. That is nothing but pure system. In mechanical system, input and output both are mechanical in nature. Electrical system, input and output both are electrical in nature. Like that, electronic and computer. So first segregation is pure system. Second one is combined system. Combined system, as the name indicates, combination of one or more systems. So electromechanical systems, combination of electrical and mechanical systems. Thermo-mechanical system, combination of thermal and mechanical system. Like this, there are several types in combined systems: electromechanical, thermo-mechanical, hydraulic system, thermal system, measurement system, control system, and mechatronic system. Depending upon the marks, you write it. Sometimes in the exam, they can ask explain measurement system in detail. They can ask explain control system in detail. So like that, they can frame the question. So depending upon the marks, you can elaborate the answers. Let us see individually in detail what is that. So while writing this, first you have to write the definition of mechanical system, then a block diagram of general mechanical system, then an example. Example you have to write with a diagram. Again, system, input and output. Like that you have to write. This is a common format to write in exam. Very important. Let us see pure system in detail. The pure system, the first one is mechanical system. Since it is a pure system, the input and output both are mechanical in nature. It might be linear motion, it might be rotary motion, it might be mechanical type. So here, one of the example is belt drive. Belt drive, the input is rotation, the output is also rotation. Same thing. So the same thing I have represented in a block diagram. This is a mechanical system. Output is mechanical. So if you take a belt drive as an example, it is a rotation. Input is also a rotation. So here also rotation, again it is also rotation. It is just transmitting rotary motion from one place to other place. That is the objective of mechanical system. In each system there is an objective. The objective for belt drive is again to transfer the rotary motion. Again rack and pinion is there. Rack and pinion mechanism. It is a pure mechanical system. Input is linear, output is rotary. Like that, depending upon the input and output type, the systems are classified. In mechanical system, both are mechanical in nature, either linear or rotary motion. Then electrical system, as the name itself indicates, electrical systems, the again input and output are electrical in nature. It can be a resistor, it can be a capacitor, it can be an inductor. Again, input and output are electrical in nature, purely electrical in nature. One of the example is, you can take rectifiers as an example. Rectifiers are used to convert AC to DCs. Again, the input is voltage, output is also a voltage. But here, again, the voltage phase lag will be different. Input voltage will be high, output voltage will be low. Input will be having 240 volts AC, output it will be having 12 volt DC. Again, AC, DC, both are voltages in nature. Electrical, if you take rectifiers as an example, rectifiers, output is voltage, again input is again an voltage. Got it? Like that, you can write several examples. One of the example I have taken rectifiers. Similarly, inverters are there, resistors, capacitors, etc. Then electronic system. Electronic system, the input and output will be electronic in nature. Again, there is a difference in electrical and electronic system. Electronic system will be handling the data only in digital formats, binary data. So, the differences between these two is the interaction will be digital in nature in electronics, whereas in electrical it can be anything. Voltage, it can be any volt, it can be analog or digital, but in electronic compulsorily it should be digital. That is a condition. Electronic, the input voltage, again the output voltage, again difference. These two are in pure form of digital. Take an example of LED diodes itself. Diodes, any solid state switches. Input is electrical, electronic, and output is also electronic. Again, those two are in digital forms. That is important in electronic systems. Then computer systems. As we know, there is no pure computer system. Computer systems are integrated with electrical and electronic. Hence, what we will say is the data which is handled by the computer system is always digital in nature. Again, there is a constant in electronic system. If you take some of the solid state switches like thermistors, there is a temperature. Again, the temperature will be in digital format. But whereas in computer, since computer is handled with microprocessor or microcontroller, everything should be in digital. That is a condition in case of computer system. Again, there is a small confusion in between electronics and computer system. Again, the interactions is almost same. Basically, what we are giving computer system, the input to the computer system and output to the computer system is electronic in nature. And that confusion will be always there because electronic system is an integral part of computer system. Got it? Almost the same thing will be there. Then next comes combined systems. Combined systems means you are combining two systems. Mechanical system is combined with electronic system. Mechanical system is combined with electrical system. Mechanical system is combined with electronic system or any other electrical system. You can have one or more interactions. So what we are looking is, we are looking only basics. Basics, that means only two systems we are seeing. There might be four systems. The systems may have thermal system, mechanical system, electronic system, and a computer system. So those things will be there. So what we are seeing is, we are seeing only simplest type of combined systems. Simplest means only two, 1 plus 1 like that. The first system is electromechanical system. So in electromechanical systems, generally how you can analyze is, first word you take it for input, electronic input, next is output. The system may have also reverse. It might have mechanical input and electrical output. Like that it is also possible. Electromechanical system is basically a fan. The fan is having a mechanical output, rotation, and input is electrical input, voltage input. So if I represent electromechanical system in a block diagram, it will be like this. The output is mechanical in nature, the input is electrical in nature. Even it is also reverse. The output can be electrical, input can be mechanical. That is also electromechanical system, the same thing. The example for this is motor, again rotation. Rotation is the output, voltage is the input. So this is electromechanical system. Electromechanical system is the combination of electrical system and mechanical system. Almost all the words are explanatory. Then let us go to thermo-mechanical systems. Thermo means heat. Mechanical means mechanical rotation, linear or rotary. Again, thermal system is combined with mechanical systems. It is thermo-mechanical system. So the basic block diagram representation is thermo-mechanical system. The output is mechanical and input is thermal. The example for that is engine. In engine, the output is sometimes in engine what you can say is, you can take linear movement of the piston, or finally you can take rotation movement of the crankshaft, linear or rotary. So that's why I have mentioned both the things. You can take anything, either rotation or linear. Specifically, if you want to say about engine, it is linear movement of the piston, that is the output. And again, that is modified to get rotary motion finally in the crankshaft. You can write anything. The output is, if it is linear also, rotary also, the output is mechanical in nature. Input is heat input, heat energy is the input. The conversion of fuel, that is nothing but heat. Chemical energy is converted into mechanical rotation. Chemical energy is burned in the form of combustion process. In the combustion, you will be getting lot of heat. That heat is nothing but input to the engine, and output is mechanical rotation. That is what you are getting in the wheels. Like that, there are several examples. This is not only one example, there are several examples. You can quote any one. Then hydraulic system. Very important thing is, specifically in hydraulic system, the input is fluid energy, we will say. What is fluid? Fluid is, again, it is a substance which is capable of flowing. Again, there are two things. One is liquid and another one is gas. If I say hydraulic system, specifically, I need to say it is a liquid. So the input hydraulic energy will be given in the form of pressure. So that is nothing but liquid. Oil, that is converted into a rotation, rotary movement. You take an example of pump. In pump, what you are getting is fluid as an input, and output will be the linear motion. In motor, the fluid energy is the input, output will be rotation. Again, both the things are mechanical outputs, input is fluid energy. If you take hydraulic system, liquid is the input. If you take pneumatic system, gas is the input. So specifically, we will use air. In pneumatics, we will be using air. So air as an input in the form of fluid energy. Again, pressure, the same thing. Both the things you will be calculating analogously. Then thermal systems. Very important thing is thermal systems. More so ever in mechanical, what we will deal with thermodynamics more. Again, all the basic systems are thermal in nature, that we are converting to an mechanical or electrical. So here thermal systems, one of the example for thermometer. Thermometer as an example. Thermometer, how it will be, again you will be placing thermometer. Thermometer will be sensing the temperature of the body. That temperature is converted into linear motion of the scale. It is nothing but here temperature is converted into pressure. Pressure mm of Hg. So linear scale it will give. Like that, there are again several scales. Celsius, Fahrenheit, basic scale what I am explaining. This is one of the system, thermal system. Specifically, if we say only a thermometer, temperature is the input and output is the Celsius scale or Fahrenheit scale, which is cause of linear movement of mercury. That is one of the example for thermal system. So there are again several systems. Even engine is also one of the example for thermal system if you are saying temperature as an input. So in each end applications, you can modify the systems based on input and output. So while writing the block diagram, you can quote any examples, but specifically when you say thermal systems, input should be a temperature or output should be a temperature. So remember that while writing the block diagram. Most of the cases, input is always temperature in the nature. While writing this block diagram, if you write hydraulic system, input should be a fluid, hydraulic energy. If you write thermal system, input should be a temperature compulsory. So like this, you can remember easily. Then measurement systems. Measurement system is somewhat different than this system. Directly we cannot write a simple block diagram for measurement system. Generally in the measurement system, what we will do is we will measure the quantities. That is called as the measured variables is called as measurand. Suppose you take this as an example. Initially, the input will be flows through a sensor. A sensor is a device. Before going to sensor, transducer you have to know. Transducer is a device which converts any physical phenomenon into a energy. That is or simply we can say one form of energy is converted into another form. Here when I say transducer, it is basically doing some change. It is inducting some change. So any changes incorporated, that is nothing but transducer. For the transducer, the input can be anything. It can be analog or digital or anything. The output can be anything. Again, it is an analog or digital. But if you take a sensor, the input to the sensor will be output of transducer. And the output of the sensor is compulsorily should be digital form data. It need not be analog. So that is very important. So basically sensor, what we will say is transducer plus signal conditioning. The output of the transducer is conditioned in order to give a required form of output. So it can be amplification of the signal, it can be attenuation of the signal, it can be analog to digital conversion or digital to analog conversion. So the output from the sensor is always in modified form, it is not generalized form. In other words, we can say the output of the sensor is always a digital data. That we can do. After that, there is a sensor. The sensor again, transducer plus signal conditioning. Those two things will be there. Then again, signal conditioning. So this signal conditioning is different, just you are modifying the input. This signal conditioning is different. I want in some of the data, the temperature is to be sensed. I want temperature in digital format. How to get temperature in digital format? You incorporate intermediate modifying devices here. Intermediate modifying devices is you incorporate analog to digital converter. If you incorporate analog to digital converter, the temperature input will be sensed, that will be in the analog form, then it will be converted into LED strips. That LED strips you will be getting display as 28 degrees Celsius. So that is the output. The output what you are getting is a display in LED. For that you need to condition the input. So this is one of the example for measurement systems. Why this is essential? Why this is essential? Suppose in industry you need to monitor the temperature. There is a temperature controller. If I just place a thermometer, due to the deflections of light or anything, I cannot able to see what is the deflection inside the thermometer by measuring the mercury. Again, if I want to measure that, again I have to go nearby to the object, I have to see what is the liquid level, where is mercury. Again I have to read that. It will take some 2 to 3 minutes. Suppose if anything dangerous happens, I cannot rectify it. If I have an LED display like 28 degrees Celsius, 33 degrees Celsius, 40 degrees Celsius, directly seeing the LED requires 1 second. If I see like this, 40 degrees Celsius, directly I can take an action if it is going beyond the limit. So in such cases, that modification of analog is essential. So like that, measurement system plays a vital role. Again, speedometer. Again, in the speedometer, you know that speed limit will be given 80 km per hour. Again, if any police is standing, suddenly you will be decelerating. If that speedometer is given in a different scale, then analyzing the speed itself indicates some time. So again, there is an incorporation of digital display for all the vehicles. By seeing the digital display, you will be knowing 80.2 km per hour. Yes, exact. So like that, the modification of inputs are essential in some of the cases. Again, there are a lot of things are there. You can give many examples for measurement system. One of the examples what I have quoted is thermal system and another one is speedometer. While writing the block diagram, again you have to write what is the output, what is the input. Rotation through worm wheels, output is speed. What your speed is getting on the speedometer. Then control systems. Again, one of the integral part in mechatronics is control system. In each and every phases, controlling is essential. So here, the arrangement of elements in a rationalized manner to achieve an object, it is a system. Control is nothing but to command or to manipulate or to direct itself. Whenever you incorporate a switch with the lamp, the switch is making or commanding some instruction to the lamp. Irrespective of your need, the switch is going to helpful. If I want a light to be on, just I can on a switch, I will get a light. If I don't want, I can switch off. If I connect lamp directly to the main powers, irrespective of my need, the light will glow. So like that, the switch is making certain action on the lamp. So this is nothing but control systems. In every stage, there are several control systems. Even an accelerator, it is a control system. The control systems will be there from simple example to complex space exploration. So that is one of the things. So again, control systems are classified into two types based on presence or absence of feedback. If there is a feedback loop is present, it is a feedback control system. Whenever there is a feedback means we are measuring the output. After measuring the output is compared with the reference value and determines error. So this error will be fixed in the next cycle in the form of manipulated signals. Very important case in the control system. If there is no feedback means you are not measuring the output. This is called as open loop system. The systems without feedback. The system with feedback is nothing but closed loop control system. The loop is closed. How you are closing means by measuring the output. This output is measured as a feedback signal. This feedback signal is fetched to the input controller, and here what happens is the controller will compare feedback signals with the reference input. Next cycle it will be fixed. Say for example I am going in a vehicle. I am going at 60 km per hour. Suppose if anything dog comes suddenly, I want to put a brake. So after putting brake, what happens? My speed is reduced. Initially first I will see the odometer reading. It is giving 60 km per hour. My reference is I need to reduce the speed to 0 because the dog is closely coming. So what I will do is I will apply suddenly the brake. After applying the brake, my speed will be reduced. Again I will check whether it is 0 or not through my eyes. So this is one of the example for closed loop control system. First 60 km per hour, it is a feedback. I will compare with reference speed. Reference speed is again 0 because I need to reduce the speed suddenly. Then I will fix the error. 60 minus 0 is 60. I will apply sudden brake. So like that, there are several examples for control system. This is one of the manual speed control system example for control systems. Next, mechatronics. As you know, in the first class, briefly I said mechatronics is the integration of mechanisms with electronics. You are incorporating electronics technology to the mechanisms. So because of that, the flexibility will be more. So this integration is called mechatronics. Mechatronics is the arrangement of physical, it is the combination of mechanical, electrical, electronic system with the computer technology system into a single system. So that is nothing but a mechatronics. Again, mechatronics, what you are seeing is only two things. Practical cases, 4 to 5 systems will be integrated. If you take an automobile of example, if you take anti-lock braking system as an example, several systems will be integrated. Mechanical system is integrated, electronic system is integrated, electrical system is integrated. Along with that, programming, computer is also integrated. That is the practical systems. Minimum 4 to 5 systems will be integrated in nature. So this is about design of mechatronic systems. After seeing all this, again you will be knowing what are the advantages and limitations of mechatronic systems. What are the advantages of mechatronic systems? Advantages itself indicates the quality will be more. You are incorporating electronic technology with the existing mechanical one. So the quality will be more. Because of that, also the productivity is also more. Why productivity is more means because it is flexible. It will come under batch production. It will be easy to manufacture the component. Then compared to mechanical alone, this technology is helpful, but there should be a mechanical system. We cannot eliminate computer, we cannot eliminate the monitor. Without monitor, nothing will work out. So compared to single ones, this is very flexible. Again, vehicle, starting of the vehicle, I need to have a starting mechanism, mechanical. I cannot eliminate that part. I can incorporate electric switch. So that electric switch will be causing more flexible. That is better than a single kickstart system. Then flexibility is more, yes. Always the flexibility will be more in case of electronic system. Always mechanisms is robust in mechanical systems. Electrical system will be having more flexible. If you integrate, the flexibility of the system will be more. We cannot get robust in electrical system. We need to get robust only in mechanical system. We cannot use electrical system in that cases. For mechanical system, yes, with switch, that is more flexible. Mechanical system with a small controller, which is more flexible. Like that, the flexibility of the system will be more. Then attractive products. Attractive products, again, giving a switch will accommodate a small space instead of giving a lever. That is one of the flexibility, and aesthetically it will good, nice. Again, the process, nowadays it is not a quality. Nowadays, after the process, we are not getting any quality. In the process itself indicates it is having some quality. So this is an era of quality assurance. In the process, what I will select the process, that process itself will be ensuring this quality will be achieved. So In that cases, attractive products can be because of aesthetics, attractive product is because of advancement in technology, anti-lock braking system, electronic braking system, like that. Anti-lock braking system, you are getting flexibility because of addition of electrical system, and also it is attractive feature because it will avoid wobbling of your vehicle on a track. It will keep your vehicle in a smooth fashion. The turn will not go out of the road because of higher centrifugal force. That is one of the attractive feature. Then accuracy and precision is more. Yes, whenever you incorporate an electronic technology, the accuracy will be more because you are measuring the quantity in terms of electronic quantities, 1 voltage, 2 voltage. Again, in this conversion, always there is a flexibility, always there is a accuracy, and it is more precise. Always electronics are precise. You are measuring mechanical quantities by converting that to electronics, and you will be measuring the temperature. Say for example, 75 degrees Celsius. You will be measuring 75.001 degrees Celsius. So that precision will be always there in electronics component. Then always any system will have limitation. Let us see what are the limitations of mechatronics. The first limitation is expensive. Yes, when I want to incorporate an electronics technology to the existing one, the electronic system cost will be adding. That is one of the expensive thing that we cannot avoid. Next, high initial cost. Yes, always high initial cost will be there because whenever I want to interface electronic and mechanical thing, I need to have an interface circuitry. That interface circuitry is a microprocessor or microcontroller. Again, it will add cost. It will be high initial cost always. Then, inputs and outputs can be monitored. To be monitored specifically. If I correlate a wrong one, what happens? If instead of temperature, if I use another type of sensor, then the input correlation will be wrong. If the input correlation will be wrong means the whole system is wrong. So, identifying input and output is compulsory and is must. It cannot be avoided, and those inputs and outputs to be monitored frequently because today my vehicle is giving 40 km per hour at 40 km per hour. Tomorrow it may give 40 km per hour at 60 km per hour. So I need to know what is the repeatability of the vehicle. That is very important. At same instance, I have to check. So I need to monitor frequently what is the input and what is the output. Then again, specific problems will be there. Suppose I want to incorporate a mechatronics technology to the washing machine. Yes, I want to do a hi-fi washing machine. Automatically it will be sensing what is the degree of cleanliness of the cloth. If I do that, I need to bring a device to measure an output of degree of cleanliness of cloth thoroughly. If I do that, the cost will be more. I need to spend 1 crore for washing machine because of degree of cleanliness of cloth to be measured, no? Yes, almost in some of the systems, there is a specific problems. You take an example of a breast toaster. I wanted to make automatic. Again, I want to bring a feedback device which will measure what is the toast of the bread. Again, the cost will be more. So those are the limitations of mechatronics. Let us take an overview of mechatronics. There are 3 things. One is mechatronics will be coming under design, marketing and manufacturing. Again, in design, mechatronics will be useful in terms of aesthetic products. In the marketing, it is also useful. Mechatronics products, lots of advertisement will be given with ease of flexibility. Manufacturing, in each and every phases, there is a conveyor system, there is a linear movement system that will be integrated. So this is one of the overview of the mechatronics in the design field, marketing field, as well as manufacturing field. So this you have to, when they ask what is the overview of mechatronics, you have to write mechatronics in design field, mechatronics in manufacturing field, and mechatronics in marketing field. Like this, the flexibility of mechatronics will be more.